Have you ever faced a coding challenge that seemed impossible to solve? It can be incredibly frustrating, right? If you're dealing with a tricky implementation in C++, you're in the right place. Today, we're diving into a common question about error handling in callbacks. I totally understand how overwhelming it can be to manage a complex class hierarchy in C++. You're not alone in this struggle. Many developers face similar issues when trying to implement flexible error handling in their code. Here's the specific situation we're looking at. A user recently asked, "What's the best way to implement an error callback in my C++ code?" They provided a detailed background about their class hierarchy and the challenges they face with error handling. Sound familiar? Let's explore this together. So, what's the core issue here? The user wants to implement a flexible error handling mechanism in their visit function, allowing for user-defined error behavior instead of a hard-coded throw statement. This is a common challenge in C++ programming, especially with complex hierarchies. And stick around. At the end of this video, I'll share a powerful tip that can simplify your error handling in C++ and make your code cleaner. To implement a user-specified error handling mechanism in the visit function, the user should start by modifying the visit or impl structure to accept an additional parameter for the error callback. Next, the user should ensure that the visit function can handle both the function and the error callback. This involves updating the function signature to include the error parameter. Now, the user can implement specific cases for handling the error callback. This includes checking the return type of the error function to ensure it matches the expected behavior. Finally, the user should test the new implementation to ensure that both the normal and error cases are handled correctly. This can be done by creating test cases that invoke the visit function with various inputs. Fun fact, did you know that C++ was originally designed for system programming? It's evolved so much since then, but the challenges of managing complexity remain a hot topic among developers. Now let's look at the answers provided by other users. This user suggests an alternative approach to handle the error behavior in your visit function. Instead of writing multiple specializations, they recommend isolating the compile time branches into a separate function called error dispatch. This function will manage the on-error callback, allowing you to call it within visit impl, call when a type mismatch occurs. Now let's see a response from a different user. One alternative approach suggested by a user is to use the variant feature from C++17. This allows you to define a base value as a variant type, which can hold different types like int, double, or string. They recommend using a static visitor pattern to handle operations on these variants. In their example, they demonstrate how to create a variant and perform operations on it, including handling mismatched types. This approach simplifies the error handling by allowing you to define behavior for unsupported types directly in the visitor. Here's the tip I promised. Always consider how error handling can be made flexible in your designs. This not only improves code readability, but also enhances maintainability in the long run. And there you have it. By implementing a user-defined error callback, your C++ code can become much more robust and easier to manage. If you found this video helpful, please subscribe for more coding tips and tricks. And remember, keep experimenting with your code.